So hello guys, what's up? We are back again with another question from our DSA series. So let's get started. So guys, today our question is, we are given a graph and we need to represent it using adjacency matrix and adjacency list. And also we need to compare which one is better in terms of space complexity. So let's get started. So for adjacency matrix representation, we will be using a n cross n matrix, where n is the number of vertices in the graph. Now, as we can see that since the graph is undirected in nature, so if there is an edge from A to B, then there also will be a edge from B to A. Hence, the matrix will be a symmetric matrix. As we can see that I have denoted 0 by A and 1 by B. So we can see that. So let's see, sir, since there is an edge from A to B, so there is an entry here. Similarly, there is an edge from B to A. So there is an entry here. So likewise, it is done. Definitely, it is using O of n square space. We will do the space comparison later on. So let's see the adjacency list representation. So in adjacency list representation, we will have kind of an array of linked lists, where each node of linked list represent the adjacent vertex as well as the edge weight, which is required from traveling from the vertex which is in consideration to the adjacent vertex. So as we can see that the vertex A has two neighbors. Just a second. The vertex A has two adjacent neighbors B and C. So in the list, we will represent it by a linked list of length 2. That is 1 and 4, 1 and 2 respectively, with edge weights 1 and 4 respectively. Likewise, we can do it for all the nodes. So let's see the complexity comparisons and which one is better in which case. So clearly, the matrix representation takes O of n square complexity, while the linked list representation takes O of n plus 2e, where n is the number of vertices and 2e will be the total number of nodes in the linked list. It is very intuitive as E is the number of edges. Let's say E is the number of edges. And for each node, since it is an undirected graph, if an edge is between A to B, so there the same edge will be also represented in B to A. So that way it will be repeated. So it will be 2E edges. So, but on the sake of it, we can see that O of n square is higher than O of n plus 2E. But for dense graphs, it is recommended to use the matrix representation, because then this E will increase. Let's say for a complete graph where every node is connected to each and every node. So it is recommended to use n square type matrix type representation rather than this sparse matrix. Then this E will increase very exponentially, very highly. So this we will use for relatively sparse graphs, and the matrix representation we will use for dense graphs. So yeah, guys, this was all from this question. Thank you so much, guys, for watching this video. Just in case you understood the video, make sure you hit the like button, press the subscribe button, share it with your friends. We shall see you next time.